a wave is generated at this point of amplitude A. Let T be the tension in the rope. This one. So what will be the, we do have two junctions. You can see there's a one junction here and the junction here. So let T be the tension in the ropes, and I'm going to generate pulse. So what is the time taken by the pulse to move from one end of the wall to other end of wall, and what will be the amplitude of transmit and reflect pulse in each part of the rope. So let me describe the question. A pulse is generated at one end. At the left end, I'll write it. Left end of string of linear mass density mu. Find the amplitude of reflected and transmitted pulses in each string. There's a primary. Later on, we'll calculate the time also. Let T be the, let T not be the tension in the ropes. Okay, now first we'll calculate what is the speed in the first. I'll call this as the first string, second string, and this is third string. So what is the speed of the wave in the first part? T naught by mu. Second part, T naught by, we'll make symbol 4 mu. It'll be easy for us in calculation. Okay, this one. Now, from where to where the wave is moving, look at the first boundary. At the first boundary, at the first junction, the wave is moving from right to denser. Then what do you expect the reflected pulse? It should be inverted. Okay, clear this. So this will be AR1, I'll write it. And this will be the transmitted pulse. AT2, I'll write it. Then this transmitted pulse, what will happen? Now will become incident pulse for this boundary. So a part of wave will be transmitted and it will move with a speed v3 in the second medium. Let this be AT3 and a part of wave will be reflected. Okay, there's a basic necessary condition. Okay, let's see this now. We are interested in AR1, no? So first we'll calculate one by one. AR1 should be equal to speed of the wave in the denser medium minus that in the, what is V2? Speed of the wave where transmitted pulse is present. I want, let me do some changes because I wanted to reflect some concept. This will be a better idea. I made some changes because the wave now at the first boundary, the wave is moving from, I'll give the boundary name P. And what is this boundary? Q. At boundary P, the wave is moving from right to denser. What about here? At boundary Q, the wave is moving from denser to rarer. Let's see what will happen because let's compare So we'll get some any information that'll be very useful. Okay, now what is the formula? The speed of the transmitted pulse minus speed of the reflected pulse, sum of divided by again V2 plus V1 into AI, and AI is equal to A. We know V2. What is V2? V by 3 minus V A. So how much it will be? Minus 2A by 3. Will I agree? This is the amplitude of reflected pulse in the first medium. We'll go for amplitude of transmitted pulse in the second medium. So this should be equal to A2 should be equal to V2 plus now V2. What is V2? V by 3.
Sir, AR1 should be minus A by 2, na, sir?
You get A by 2, ma. Minus 2 by 3, 2 by 3. A by 2 will come. I got plus A by 2. You see that minus A by 2. This is plus A by 2. Okay, I'll do justify my the assumption, because that will be very strange. You can say some students will answer, why only you are assuming like that? So what is AR1 minus A by 2? Okay, calculation, check it once. I think everything is fine here, no? Yeah. Let me, I'll color it so that you can notice it. Now, what is the displacement? No, let's calculate 83 and AR2. We'll get some better picture. I do have space, no? Yeah. Find the amplitude of in each string. Okay, now look at the diagram, and we'll calculate the other things also. First, we'll go for the value of AR2. What should be AR2? What shall I write? Don't write, see, it's not a formula of speed of the wave in denser medium minus speed of the wave in rare medium. No, not like that. What is V2? V2 is the speed of the wave where transmitted pulse is present. That's what this I took here. So no, I should write V3 minus V2, V3 plus V2 into 82. Try to see the formula. This will become incident pulse for second boundary. Don't write speed of the wave in the denser medium minus speed of the wave in the rare medium. Some books they're given, it's a wrong thing. I'm making things clear. Some books, in fact, they define like this. It's a wrong thing. What is V3? V by 2, V by 3. What is 82? Is A by 2. A by 10. So what is AR2? Oh, okay, okay, ma. Yeah. R2, AR2 should be erect. Yes, yes, I changed it. Okay, I got this one now. A by 10. So what do you mean by A by 10? It should be erect. Similarly, we'll go for 82. Should be equal to 2V3 82 by V3 plus V2. Anybody value? Anybody value? 82. 82 value. Somebody just simplify. 3A by 5. Huh? 3A by 5. Okay, let me write it. Okay, I do have all these answers. Let me put it. I'll now justify what all we did. Because see, I assume something which will be very difficult for students to accept it. Now I have brought a numerical where what we done is right, I can feel. Okay, now let's do one thing. Superposition of this is a minus a by 2 will be a by 2. That should be equal to a by 2, correct? No, come further. Superposition of these two should be equal to this. No, what is 82? Value of 82 is a by 2. A by 2 plus AR2 should be equal to 3a by 5. Justified why I should take positive. Like I say, I wanted to justify this condition. I wanted to justify this one. Positive sign. Sir, why can't you take negative? No, it all depends upon the wave reflected by denser or embedded. So therefore, let this be an algebraic sum. I think this will be more systematic, no? Here. A minus a by 2 equal to this one. 82 plus AR2 is in fact 83. Okay, one some very important thing is that anybody noticed here. So what happens here? The wave is moving from rare to denser. The reflected pulse will be inverted. The wave moves from denser to rarer. The reflected pulse will be inverted. What happened to transmitted pulse? No phase change. Reflected pulse, there'll be phase change. What happened to frequency of all these waves will remain same. Lambda depends on medium or depends on speed. Are you able to understand? So all these waves will have same frequency. F, F, F. Frequency will not change due to transmission. I think that we know it. No, anybody noticed? I'm something asking very important. I want you to notice. That's all. Rather than I quote, you must make observation and tell me. Okay, look at the AT2 and AR1. Look at AT3 and AR2. Which will be greater? AT2 is greater than AR2, no? So when a wave moves from denser to rarer medium, the amplitude of transmitted pulse will be more than amplitude of incident pulse. When a wave moves from rare to denser, the amplitude of transmitted pulse will be equal. The amplitude of transmitted pulse will be less than that of incident pulse. I'm not bothered about this. I'm bothered about these two and these two. This is incident pulse. This is transmitted pulse. What is the amplitude of transmitted pulse? Less than that of incident pulse. Come for here. What is the amplitude of transmitted pulse? Is greater than that incident pulse. It can happen. So what is the conclusion we can make it now? So when a wave moves from, I think I'll write it here. This will be. What is the conclusion we can make it now? This is some important conclusion. When a wave moves from rarer to denser medium, amplitude of, I'll write it in next. It will be very, looks odd writing here. Let me write here. There's a very important point. When a wave moves from rare to denser medium, the amplitude of transmitted pulse will be less than this is one thing. Similarly, when a wave moves from denser to rarer, the amplitude of transmitted pulse will be greater than amplitude of, sorry, this is incident, no? Oh, no. Please do notice this less than, and that these terms are very important. When you go for advanced paper, no, you do get more than one options. Most of students, they feel it's a just information. How we are able to conclude this only through numerical, no? So what students will do is they'll try to remember. In physics, nothing called like a memory now. I'm putting in another way. So to conclude these particular points, what happened? We must have a numerical. Through numerical only I'm able to tell, no. Otherwise, very difficult. So more than one options, why you find very difficult? Because you think that this is some data which you should remember. No, there's a data which you're supposed to analyze through an example. Without above numerical, how do I can conclude this? You only look at, so you look at the especially SC Verma, we do have some objective questions where you have supposed to draw a diagram, you should have assume some numerical, and through that numerical only you can conclude. Uh, uh, Yochin, you are asking, sir, these statements are always correct. Okay, no, you only justify it because I discussed one numerical, no. Is it only for this numerical or is it a generalization? It's a generalization for any wave, longitudinal, transverse, mechanical, non-mechanical, anything. That's the basic idea. These statements are very dangerous, especially wave sense or no, you do get very lot of conditions. So student must be aware of those conditions. Okay, I agree this. There's a condition. Huh? Any doubt, please do clarify because these are something very, very, very important part. Huh? Okay, let me take the now we'll try to draw some what all we yesterday know. Let's see that how we'll apply things. Huh? So I took some pulse, no. So let's take some shape of a pulse. I'm going to trouble you with now a series of set of questions.